Hello all, welcome to the lecture on reactive programming and reactive systems. Now, in this lecture, you are going to understand the difference between reactive programming and reactive systems. So, what is reactive programming? Now, reactive programming is a programming paradigm. So, it is a concept, it is not an implementation. Now, you have programming paradigms like OOP, imperative, functional, so on and so forth. Now, in OOP programming paradigm, when you are solving a problem, first you are trying to understand the object model, and around that, you are trying to implement the solution. In functional programming approach, you are trying to take a more declarative approach and you are trying to avoid side effects. And in imperative programming paradigm, you are trying to understand the functions and you are trying to implement side effects to solve a problem. So in reactive programming, these are the main characteristics that you are going to encounter while solving a problem. You have asynchronous invocations, and you have non-blocking threads, and you have data streams when data is exchanged, and you use events to communicate between components, and to manage flow control you can implement back pressure. So when producer and consumer are communicating with each other, the flow control has to be handled using back pressure management. Okay, so these are the core principles of reactive programming, right? Now in your right side you can see a diagram which depicts a potential architecture based on reactive programming for a web server. So you have an unblocking event loop thread, right? And you have uh, the backend services which are running inside the web server to invoke various backend calls. It can be a file operation, or it can be a database operation, or it can be external service call, right? So when a request comes, this event loop thread will take the request and it will register a callback, and it will delegate the functionality or the responsibility to another thread. The same thread which took the request will not go ahead and conduct the IO intensive backend call, right? So event loop simply take the request from the user and pass it to another thread to execute the IO intensive backend call, right? So before it delegates, it will register a callback, right? So when the IO intensive backend call is completed, it will notify the event loop, and this callback gets executed, and uh, event loop will trigger the callback to pass the response to the user. Now you can see this event loop thread is not getting blocked at all, right? But in traditional environments, when a request comes to the web server, it will create a thread, and the same thread will go ahead and do the IO intensive backend call, right? So there are many disadvantages in that approach. Firstly, the calling thread is blocked indefinitely till the IO intensive backend call is returned, right? And the second disadvantage is creating threads is a very expensive operation. Okay, but if you use event loop, you don't have the issue of blocking. Simply, the event loop thread will take the request and pass uh, the resumption to another thread, right? And you're not creating a thread on the fly as well, right? So those are the advantage of event loop based approach, which is a fundamental feature of reactive programming. Okay, so non-blocking approach is one of the core uh, signifying feature of reactive programming. Okay, so by looking at this example, you can understand how reactive systems work, right? So it will never block calling threads, right? And when data is sent back to the user or data is received to the user, you can accept them as streams and you can send them as streams as well. Okay, and you're not going to create blocking threads. Okay, and uh, when uh, when systems are communicating with each other, you can pass events. Okay, and when user is taking responses or taking data from the server, you can implement back pressure. Simply, when user is requesting, you can uh, put a uh, limit on number of data elements that you can receive from the producer end, right? So this is a typical example of a non-blocking reactive web server, right? So now you'll have a brief insight on how reactive systems are working. Okay, simply reactive systems are not blocking and they are event driven, and you can implement back pressure, and asynchronous nature is inherently built in to reactive programming based systems. Okay, so let's see what are the advantages of a reactive programming based system. And you have faster processing times simply because you are invoking asynchronous calls. You are not bound to a single thread to carry out all the operations all the way from user to IO intensive backend call. So you have delegated responsibility across multiple threads. As a result of that, your processing times will be more faster and better utilization of resources. You're not blocking any thread. Any block is not in waiting state, right? Always, all the threads are in fully functional way. Okay, as a result of that, you are utilizing resources well, right? So, given a set of hardware resources, okay, by implementing reactive programming approach, you can get more performance over traditional architectural approaches. Okay, which ultimately lead to reducing the cost. And also, these reactive approaches will work well with functional programming approaches. Okay, so when data is retrieved as streams, one of the core advantages you can utilize the functional programming constructs like filtering, mapping, reduce. Those are built-in programming constructs in functional programming languages. And also, the reactive programming will help uh, solution providers to implement event driven microservices architectures, right? Now, if you take microservice architectures, you are compartmentalizing your application into several components, right? And you need to communicate with these components, right? So ideal way to communicate between components is through asynchronous messaging, right? And if you use reactive approaches, asynchronous non-blocking approaches are built in, right? So event driven microservices architectures can leverage the reactive programming principles. Okay, and RX Java, Akka, Eclipse, Vertex, Project Reactor are some of the open source reactive programming APIs available in the market these days, right? And Project Reactor is one of the modern reactive programming APIs released to the market. Okay, now let's see what are reactive systems, right? Now, if you go to reactivemanifesto.org, you will find a specification which clearly stipulate the features of a reactive system, right? Now these days, uh, we are in cloud computing era where systems are dealing with large data sets, and IoT uh, and machine learning, so on and so forth, are crucial user requirements these days, right? So when you are dealing with large data sets with with the expectation of millisecond response time, 100% uptime, high throughput, infinite scalability, you can't rely on traditional software architectures, right? So you have to implement reactive based architectures to cater the highly agile, high end user requirements, which is the reality these days, right? So, when you are implementing systems for cloud based, multi core, myriad of servers, you have to implement your systems as reactive systems, right? Now, uh, there are four core principles of a reactive system. A reactive system should be responsive. That means it should handle requests in a reasonable amount of time. Any request should be able to receive the response within a reasonable amount of time according to a SLA, right? No request should receive response after significant amount of delay, right? So one of the crucial feature of a reactive system is it should be responsive, that all the requests should be responded within a reasonable amount of time. Okay, and reactive systems should be resilient. That means it should be able to recover from failures, and the user operation shouldn't be disrupted, right? So stay responsive in the face of failures. It can be server crash, timeout, 500 errors, right? So by implementing features like replication, redundancy, delegation, you can achieve resiliency in reactive systems. And also, a reactive system should be elastic. That means it should stay responsive under various loads, right? Be it 1 million requests, be it 10 million requests, system should be able to scale up and scale down and recalibrate its resource consumption. So that is called elasticity in a reactive system. And also, reactive systems should be message driven. Now in modern reactive systems, there are many components involved in serving a business requirement, right? So these components are interacting using asynchronous message passing. So so by achieving this compartmentalized approach, you can achieve uh, decoupling, location transparency, and at the same time you can enable asynchronous message passing. Okay, so these are the core principles of reactive systems. Okay, so by implementing these features, you can cater modern user requirements of sub-millisecond response time, scalability, 100% uptime, high throughput handling, so on and so forth, right? And if you go to reactivemanifesto.org, you can see the specification. Right now, this is the Reactive Manifesto. So you can see, right? So it's a specification. So by going through this specification, you can understand the core principles or core features of a reactive system. So in your free time, you can go to this URL and read the specification from top to bottom. Okay, so here I just highlighted the core principles of a reactive system. So when you are implementing um, modern systems, you must follow the reactive approach in order to cater uh, advanced use expectations, which is the reality these days. Okay, okay. Now we'll see what is reactive stream specification. If you go to this URL reactivestreams.org, you'll find a specification, right? So now when you are implementing reactive programming APIs, you can adhere to this specification. So this specification defines a standard for stream oriented libraries. So when you are implementing a reactive stream library, you have to adhere to this reactive streams.org specification. It defines a minimal set of interfaces, methods, and protocol which any language should implement when they are implementing a reactive library. Right? Originally, this specification was stipulated by Lightblade, Netflix, and Pivotal, and later Oracle, Twitter, Red Hat was joined to implement this specification and to standardize reactive APIs. Okay, and it defines things like processing a potentially unbounded number of elements, how a stream should be uh, handled in a sequence, and how asynchronously passing elements between components, how to implement non-blocking back pressure, and its specification defines four key interfaces: publisher to to represent the producer, and subscriber to represent the consumer, and subscription to define the context, and processor to process the data, right? So this specification simply gives a textual uh, implementation of the reactive specification. And if you go to this GitHub URL, reactive streams JVM, you can get the JVM implementation of this reactive specification. Okay. Now, if you go to this reactivestreams.org, simply you will get a uh, textual implementation of the specification, right? And the code based implementation for the JVM is available in GitHub Reactive Streams and Reactive Streams JVM. And you also can come up with the implementation for these reactive streams by your own language by following the specification, right? And it has uh, the contract, and it has a set of test cases to be passed in order to ensure that your implementation is complying with the reactive streams.org. So in your free time, you can go to this URL and see how reactive specifications are uh, implemented. Okay. Now in the reactive stream environment, this is how the data flow happens. Okay, so you have the reactive client, the consumer, and then you have the producer, right? So um, So this producer can be external API, file, database, or it can be a REST API, whatever, right? And assume this is the consumer, which is your client application, and this is how the streaming works in a reactive environment. So it's a reactive client. You send a request for data, and you pass it to the reactive producer, and immediately you will get a return, right? Because the data transmission happens asynchronously. So once the data is processed by the external API, it will call on next on on the consumer. So on next data 1, data 2, data 3, data n, and once the data stream is completed, this uh, the producer will send on complete event, and if there is error, it will send on error event. So based on the event, it will either uh, either collect all the data or it will get the error response. Okay, so this is how the data flow happens in a reactive environment. So when you're requesting a data, if you want only four elements, you can say I need only four. So you just say request with some parameter four. Then the producer will send only four data elements, and after that it will invoke on complete. Okay, so that's how the data streams uh, works in a reactive environment. Now, Project Reactor, right? Now, Project Reactor is a reactive library for JVM, right? So, Project Reactor is implemented by Pivotal, right? It is uh, it is based on reactive stream specification. As I said earlier, uh, there's a specification at reactivestreams.org endpoint. So that specification is implemented by Pivotal, and Project Reactor is the name they have given, and it is back pressure ready, and it's fully complying with the reactive stream specification. That's why it's called a fourth generation uh, reactive API. If you take Akka, uh, Eclipse Vertex, uh, RX Java, they are not fully complying. There are lapses in the implementation. Okay, but if you take Project Reactor, it is fully complying with the reactive stream specification, right? And it provides providing rich and functional reactive APIs, and it is incorporated with Spring Framework 5, and it's using the Netty server to give a web-based implementation for the reactive implementation, right? So they're using Project Reactor. You can uh, you can consume all the reactive features in uh, in the implementation. Okay, so I hope you get a clear understanding about the reactive programming, reactive systems, and various reactive stream specification implementing APIs, right? And that's all for this lecture, and I'll see you in the next lecture. Thank you.